Alright, the side splitter theorem uses, and we're going to do it without proof this time. Last time my video ran 20 minutes long, so that is plenty of time. We'll do it without it this time. So a line parallel to a side of a triangle intersects the other two sides so that the resulting segments are proportional. So what does that mean? Well, what we have here is a little app that would show you how all of this what it means. So DE in our case is parallel to AC, and if you notice, that means that BD over DA over here, BD over DA is equal to BE over EC. And then I have the numbers, the links of each of those sides, like there's DB, there's DA, there's BE, and there's EC. And I have those links, and then right below that, I have what each of those sides divided by each other is. So what's cool is I can move this thing around and kind of show you that, yes, indeed, well, I'm going the wrong way. There we go. Yeah, as you move D up, it changes your proportions, but they still stay equal. You have equal proportions. And we can change just about everything here. And those proportions stay the same. So no matter how I change it. Now this is not a proof, but it just kind of shows you what's going on. That this number divided by this number, so dB divided by dA is equal to BE over EC. So we can set up those proportions. Doesn't matter how we do that, they're always going to be equal. You know, we can move it all around. And notice how DE and AC stay parallel no matter how I move them. And so that's key there. So that's what the side splitter theorem is. What we can do with it then, because of that, is solve some triangles. So this first one, and I'm going to make this go kind of fast, so bear with me. So we can set this up as 18 over AD equals 10 over 7. And then if you cross multiply each side, again, I hate to use cross multiplication, but it works for us. Just don't use it all the time. Make sure you have a proportion before you do it. Equals 18 times 7. And so 10 AD equals 126. Then you divide by 10. And AD equals 12.6. So that's kind of quickly how you could do it. Now, setting up the proportion, you could have also set it up as 10 over 18 equals 7 over AD. And there's several others, but those are the most common. And they all are based on how proportions, the properties of proportions. All right, with that in mind, be careful. So here I give you an example of, we want to find AC this time, this bottom one. Okay, side splitter theorem doesn't work here. And I can just show you really quickly why not. So if you tried to use it, so 3 over 2 is the same as 9 over AC, we end up with a problem really fast. So 3AC is equal to 18. You divide by 3, and AC is equal to 6. Well, if you look, 6 doesn't even make sense there. I mean, DE is 9, for God's sakes. So with it being 6, we're going to have to do something different. Well, we need to move back to, when side splitter doesn't work, you got to go back to similar triangles and draw out the two. So we've got the small triangle on top. We've got the big triangle on the bottom. I even hate using the side splitter theorem just because of that. So this side is 5. If you know that bottom triangle, even though I did a really poor job of drawing it. There's what it is. So this is 8, this is AC, this side is 3, this side is 9. Oh, never mind. That is not 8. Excuse me. That is 8. Just messed that up because 8 is just dB, not BA. So sorry about that. Then you can just set up your proportions based on the similar triangles. So we know 3 over 5 is the same as 9 over AC, because 3 over 5 is your scalar factor. And so when you check that, you cross multiply, and 3AC equals 45. You divide by 3, and AC equals 15. So and that makes sense. So now AC is 15. It's got to be longer than 9. So at least we have an answer that's within reason there. So go ahead and give this a try. So this will be the last example, and I will solve it for you, but pause the video. See if you can find out what AD is. Alright, so I'm going to go ahead and set up the proportion as 9 over AD equals 4 over 12. Cross multiplying that, we know 4 AD equals 9 times 12, and 9 times 12 is 108. Then you divide by 4 on both, and AD is equal to 27. So I hope this helps you figure out the side splitter theorem. Like I say, I always if you forget the side splitter theorem, at the very least, draw out your two triangles. You don't have to make them nice and fancy, but you could do this, and this is 9. This is x plus 9. This is 4 plus 12 is 16. And so you could set up your proportions this way as well, and it would work just as well as the side splitter theorem. So see you next time, and good luck.